Hello, and you're once again welcome to MES Constructions, where we discuss all things engineering, architecture, and 3D modeling. Today, we will be learning on AutoCAD how to create an architectural plan, and I'll be making use of this drawing as a guide to the scheme of work for this tutorial. As you can see, this is a simple drawing of two bedrooms bungalow, and it has an anteroom, the dining, the kitchen, the store here. We have the master's bedroom right here, and bedroom one, lobby, and the living room. Then we have the balcony here. We will be replicating every element on this architectural plan in order to show you how it can be done in AutoCAD. But before further ado, we encourage you to subscribe to our channel for more contents like this, and also to turn on your notification bell to be first to see our latest video tutorials on AutoCAD and other contents that pertain to construction. Now, for starters, it's going to be quite demanding to go in and out of AutoCAD in order to replicate this. So, what I want to do is I want to import the drawing like this PDF. I would like to import it into the AutoCAD interface as a block, and by doing that, I'll be able to have a direct access to it as a guide in our quest to replicate it. In order to bring the drawing into AutoCAD, we can go here and then select PDF import because it's a PDF file. So I can go on to locate the file, and once I find it, I can select it, but I'm going to be leaving everything here as default. And as you can see, import as block option is available and it has been checked right here. Then I can go on to press OK. And now I need to assign a location for the block by clicking my LMB on any spot on the interface. And once I do that, it loads up and generates the drawing as a block. You can notice that the orientation is off and nothing like what we have in our PDF file. And in order to fix that, I need to go back to AutoCAD to rotate the block. To do that, you can simply use the command panel or use your RMB and select rotate as shown. The next thing to do is to pick a reference point. So I'm going to pick this point and I'm going to rotate the block 90 degrees. And now you can see that the orientation is exactly like what we have displayed in our Acrobat Reader. Before anything else, I want to assume that you don't have your project set up like this. Like I have my project set up here, and you're just opening a new file in AutoCAD and trying to begin a new project. Now, in such a scenario, you need to first make sure that your unit of measurement is set to desired specification, and you can edit your unit of measurement in Drawing Utilities as shown. Set your length type to decimal if you don't want to use the imperial system but want AutoCAD to define units as you draw. With decimal selected, you can attribute other units like millimeters to your drawing, but with architectural or engineering selected, the imperial system will be used. I'm going with 0 as my precision, and this is because I intend to use millimeters as my unit of measurement. As you know, the millimeters is already in order of 1,000 meter, and measurements below that are unrealistic in execution. For now, you don't need to touch this, and we don't need to touch this. Click on direction to set direction when you're drawing a professional architectural plan where the layout is required. Based on the information provided in the survey document, you can then select the global orientation of your layout here in order to make the location and orientation of the project in real life to be as precise as possible. And this is usually a requirement for government approval. But for now, I can simply close this and go back to press OK to apply the settings I already made. You can further ensure that our unit is set by going to Annotate to choose or manage dimension styles. We can create new dimension styles or make modifications to an existing style. I already modified the standard dimension. And this is because the default properties were not in line with my preferences, and you can do the same as well. The few things I changed here were the unit format from the default, which was architectural, to decimal. And then I also changed my precision to 0. This I left the way it is, but I turned the rounding off to 0. And in case you need to add a prefix, you can just input here. And in case you want a suffix such as unit of measurement of your choice, you can simply type it and it will be shown in your drawing as part of the details in your dimension. I'm leaving the rest as default. You can also adjust your text properties, select from default options or customize text, and then select as an option. You can also play around with these other settings as you wish, and when you are done, you can press OK. Then we can close this and return to our 2D interface. Now that we have our unit set, the next thing is to ensure that our grid is turned on and our auto mode is snapped on as well. Then we can proceed and start to work on our drawing as our project is now duly set up. We can use construction lines to align the elements in our drawings. It is also highly recommended if you are new to using AutoCAD, as alignment of elements in your drawing is important to ensure precision and accuracy of measurements. As you can see from the construction lines drawn, the lines in the block are perfectly aligned. Now, I'd like to remove this block from my layer 0 because I want my drawings to be on layer 0 and don't want to block on the same layer. So, in order to do that, we can click on Layer Properties to create a new layer and name the new layer Demo Block. Our intention is to move the block into our demo block. So I can simply click on the block, then go into the layers and click on demo block as shown. Beyond the scope of this tutorial, you could simply explode the imported PDF and work on it right away to replicate it, and you wouldn't necessarily need to have it merely as a reference block in your AutoCAD project. However, the aim of this tutorial is to show you how to draw an architectural plan in AutoCAD, which can only be effectively done with a relatable reference drawing. Before we proceed, I would also like to create another layer for my construction lines and can do that as shown. And now I can use the procedure earlier discussed to move my construction lines to the new layer that I created for it. I can also give my construction lines a different color in order to distinguish it from the lines in my drawing. Now, I can simply copy the construction line and use it to make a reference point for my new drawing on my UI as shown. I can, however, leave the baseline and leverage their point of intersection as my reference to avoid our construction lines obscuring the visibility of our model. We can simply move it behind our model as shown. We can begin by replicating this external wall, the wall of the living room, which is 6050. We can go up and select line, and then we come down here to draw from a point of intersection and type 6050. You can notice that the size of our imported block is very small compared to the size of our line, hence we need to scale it up. You can scale it up by any value relative to the new drawing, as all we need are the elements in the drawing as provided. Now that the block intersects with our new drawing, we need to move it back, and also the construction line associated with it. Then I can also move the construction line to the edge of the block. This isn't necessary, but why not? Now we have what we intend to draw here. This is the reference image, and this is going to be what we'll be working on in this tutorial video. We have this line drawn at 60504, the front wall. However, the side wall is 12825, and we can draw by typing the value as shown. We can go on to check the length of the wall at the back and then draw. It's 10900, and we can simply type that as shown. You can also go on to check for the dimension of the wall on the right side and enter the value as shown. The dimension of the front wall on the other side is 3950, and we can go on to enter the value. We can then bring down this line to a point of intersection with the other line and join both lines to close the loop as shown. Now we have something that looks like the layout of the drawing to help us to draw, or better still replicate, the existing drawing. The next thing to do is to offset the drawing, and we can simply do that by selecting the offset 2 at the top panel. Then we go back to our drawing and select a line to offset. I'd like to offset the walls by 225, and then we can apply the offset to every other line in our drawing as shown. What we are trying to do is to draw all external walls. We can use our trim tool in the top panel to trim out overlapping lines. Oh, but we can connect these lines as it seemed we somehow missed it. Then we can use our trim tool to trim the overlaps. We can simply readjust this line to imitate what we have in the original drawing by dragging it down as shown. Now that we have this layout, we can begin to work on replicating the existing plan and drawing to precision. We can begin by extending this edge. However, dimension isn't explicitly given in the existing drawing, so I can give it 2000 for now, and we can come back to it later on after drawing other elements related to it with known dimensions. Select and copy the line to make a wall of 225. Now we can either use a trim tool or simply select the line and drag it back. Both methods produce the same result in eliminating overlapping lines on your drawing. And as previously stated, we can evaluate the true length of this wall by drawing other known elements around it later on. In order to proceed, we need to check this dimension and ensure that it corresponds to what is on the existing drawing. So we have 6600 here, and here we have 6050. That doesn't correspond, and this means that we have to amend the new drawing. We can use our calculator to evaluate the error by subtracting 6050 from 6600, that gives us 550. This means that our layout overlapped by 550, hence we need to move back our wall and the lines associated with it. We can move the wall back by 550 and drag overlapping lines to intersect corresponding points on the wall as shown. Then we can check again to ensure that we got it right, and to precision it measures 6050, and when we go back here and check the existing drawing, we have 6050, and that's perfect. So now what we want to do is to create the entrance, and from the existing drawing this space is 1200 wide, so we can click on line, then come down here, don't click but snap your cursor to the vertex, move your mouse and type 1200 in the command as shown in order to make the end point of 1200 the starting point of your line. We will be drawing this wall of 675, but we need to add 225 to make up for the width of the block wall. The length of the wall is 900 and we can draw that. Then continue to the side by 225 and return to the origin by typing 675. Now the width of the wall is 950, terminating on the toilet wall. Since we already have what we need here, we can press escape and try to extend this line by reselecting the line tool. Then we can select the vertex and move it by a sum of 325, 700 and 150 as it is in the existing drawing. We can therefore extend it by typing 1175, but as you can see we also need to extend it downwards to join the outer wall. Then we can go on to track back the lines of this wall to align it with the precise location of our external wall as shown. And because I don't want too many lines in my drawings, I can select this and join them to make a single line. Then I can select this point and drag it back by 225 to eliminate overlaps in order to represent my external block wall. So now we can work on the toilet wall, and you can see from the existing drawing that we have the length as 1200. However, we have a little bit of discrepancy here, and it's because this wall is actually offsetted by 225 away from this other wall. They are arranged on the same line, and we can go back to the existing drawing to check. This was an error inherent in the layout method that we adopted. Nevertheless, we can run a construction line to be certain that the lines are in the 225 part. I can select and copy this. Use it as my reference and come down to insert it here. You realize that the line passed through the inner wall and not the outer wall of the anteroom. Now we can go back to our drawing to amend the error by selecting the affected walls as shown and move down by 225. Now I think we have it perfectly set as it should be, and we can also eliminate this overlap by moving this vertex as shown. There are still discrepancies on our layout for the toilet, but for now we can simply ignore them and fix it later on. We need to drag this back and snap to the edge of the wall as shown. Then we can draw this and join the lines as shown. Now let's try to amend the discrepancies for the toilet and the right side wall. When we look at the existing drawing, we can see that we have this toilet right here to be 1125 in width, forming the external wall. And you can also recall that our layout was drawn in excess of the balcony, which is 900, extended to the front side, which means that our dimension for the toilet needs to be recessed by at least 900 to be accurate with the existing drawing. Hence, we can proceed by creating a new wall offsetted by 900 away from the existing wall as shown. From the existing drawing, we can modify our drawing to precision once and for all, and I think it's the way to go now. Here we have 1825, and we can simply remove that from the length of our layout. Then we also have 3750 plus 900 to subtract from the width of the layout as shown. Now we can simply drag the vertices of our lines back by 4650 as shown. Then we can draw a new line and extend downwards by 1825 as shown. Type 1825 and press enter. We can now join the wall of the recess to the wall of the balcony as shown. We can also evaluate the length of the balcony from the existing plan as shown. We can now draw the balcony as shown, bearing in mind that the width of the balcony is 900 mm. Then we can trim off overlapping lines as shown. Extend and connect the amended right side of our layout to the front side as it is in the existing architectural plan. And now we can extend the toilet wall to the external wall, and I think it's perfect. Then we can proceed to clear all lines that are no longer needed in our drawing as shown. We can use our measure tool to check the accuracy of the toilet wall, and as you can see, it is indeed 1125 as expected. So we can go on to clear this line. Then we can select this line and join it to the other line, or simply delete it and extend this line to the other line as shown. We can actually take this wall and extend it to this wall, then trim off overlapping lines. Or better still, drag this to precision as shown. You should always remember to save your work. Now we can proceed with our drawing as we have the external walls of our layout drawn to precision. Going back to the toilet walls, we can simply remove 900 from the external wall to draw the wall supporting the toilet door. As calculated, the length of this wall here is 225, and we can draw that shown. Now we can proceed to other rooms in our drawing. To draw the wall between the anteroom and the dining, we can leverage our external dimensions, and we can take our dimension from here. We have 2650 plus, what do we have here? Okay, 700. We have 3350, which means we have to take 3350 from the edge of this wall. So we can go to our drawing and draw that as shown. The width of the dining is just 2300. However, we need to have 225 to indicate the width of the external wall. I can now trim off this 225 because I don't need it anymore. We could offset this by 225 or copy it, so I'll just copy it. Now, let's look at how the wall goes on this side. We want to know the length of this wall. We already know that the length of the dining is 235 and we have 1200 here, and the total length of this is 235. So we can actually easily, evaluate the length of this recess. Now, what we need to do is to subtract 1200 from 235 in order to get the length of our recess. And we can go on to draw as shown. We can draw by simply typing 1125 as shown. And it goes outside by, and just give it 1000 for now since I don't know what it is. And I can now go and check what it is, and that's 1425. So it goes out by 145 plus 25 because we need to add this particular wall because this is what makes it 650. So we have 225 plus 145. And that's 1650 right there. And we already have 1000 here, so I'm just going to move it by 650. We can take this and copy and then move by 225 as shown. Now we have this part of the drawing done. However, what do we need to do to get the length of this place as the length was not provided? Well, I know this door is 1200 and this other door 900. So what we need to do now is to snap our line through the door space of 1200 and begin to draw from that point as shown. Now we have the edge of our door and we can go on to drag the vertices of our walls to the vertices of our door as shown. I think we are done with this side of the drawing and can proceed to the kitchen. For the kitchen, we have the dining wall to the kitchen wall to P2325. Now we can either use 1200 from the passage as a reference or use the dining length, which is 2325. However, we can also take our reference from the store wall, and in this case, it is our best option given the circumstances. So instead of taking our reference here, we can go on to take it from here. And it's seemingly so much easier, as all we need to do is to copy this external wall and move it here by 1200. Now let's try that. So now we have the store drawn as shown. We can use it as reference for drawing the kitchen. To get the dimension of the kitchen wall from the outer wall of the store, all we need to do is to extend the wall by 3975. We can now extend this vertex by 3975 and do the same for the other vertex as well. Then we can draw our kitchen to dining partition wall and offset it from the external wall by 900 for the door space. In order to check for accuracy, note that the length between the kitchen and the passage wall is 1200 and 2325 for the dining. So we need to check if the length is indeed 1200 and the dining length is also 2325. Now let's check that. This is exactly 1200, perfect. We may now extend the measurement down here to check for the length of the dining wall. And as you can see, it's exactly to 3 to 5, which means that our drawing is very precise. So we have the ante room, the visitor's toilet, the dining, we have the kitchen, then we also have the store. So what is left for us to do now is to create a partition wall between the living room and the bedroom one. In order to do that, you see that it is straightforward, as we have the length of the inner wall of the living room to bedroom 1 provided. And what we just need to do here is to simply take this, copy, then move it up by 4925 as shown. You can also copy this one too and duplicate at 225 for the block wall partition. So now because we have this measurement here, it's going to be easier for us to reference and draw to position our bedroom 1. In order to do that, what we need to do is to add 1 for 50 close the wall, which is 225, and then 2 to 50, and we can do that right away. The width of this room is 3925. Now, because there is a wall here that ends here, and this door is the same size as the entrance door, and it's 1200, what I'm going to do to solve this is to go here and join this to this, then I can drag it back by 1200 for the door space, and that's going to be where our wall stops. Then I'll come over here and use my line to close that. So I have a 1200 door space here, and in order to get the wall of this room, we have the width already given as 1650. To get the recess of the wall, we can simply subtract 1200 from 1650. We have 450, and that will be where the wall of the bedroom 1 starts. So we can take 450 from the edge and have this come here. For now, let me just give this 1000. The length of the wall wasn't provided in our existing drawing, so I'm just going to give it 1125. But first, I can copy this to draw my block wall as shown. Then we can go up to select my trim tool to trim off overlapping lines, and we can also do the same for the entire drawing. Now, before we can draw the other walls in the room, we need to know the total length of the room. The total length will be the sum of 200, 225, and 1200, but you can go on to draw the toilet wall, and that is 200, implying that we will begin to draw from 2200 away from the wall on the external wall and project inward by 1450 as shown. And for the door wall, we can subtract 900 from 1200. That's 300, and it represents the length of this wall. But to get the full length, we must add 2 to 5. Now, The extension will be an addition of 300 plus 2 to 5, which is 5 to 5. And this is because 2 to 5 represents the width of the toilet wall. Then we can go on to trim overlapping lines as shown. Now, from the toilet wall to the wall of the master's bedroom, we have a length of 1200, hence we can simply copy this wall and move it up by 1200 as shown. That's the boundary between the rooms, and we can go on to stretch this line by dragging the vertex, stretch and snap to the existing wall of bedroom 1 as shown. Then we can now copy and move it up by 2 to 5 to form the block wall. Draw a new line, project to the wall as shown, and move the vertex away from the wall by 900 to draw the door space. We can also copy this and move by 2 to 5. Then we can extend the vertices to intersect with the wall of the master's bedroom. You can either copy this or draw with the line tool, but I would rather copy as shown. There are just so many different ways you can achieve the same result in AutoCAD. We are almost done with all our partition walls. What's left is the master's bedroom. Now, when you look at the master's bedroom, you'll see that we have this 150 toilet wall width. This means that we can easily copy and duplicate this wall and project it here to make this wall. And that's what we are going to do. But first, we need to work on this wall. You can simply select and move back the vertex as shown. Then we can select our line tool to join this to this. Then I can take this line and copy it, then move it by 1/450 as provided in our existing drawing. And since it's an inner wall, we need to duplicate for the block wall thickness outside the room. And now we can come over here, select the vertices and move up by 900 to draw the door space as provided in the drawing. Then we can close this wall. You can always use enter to repeat the last command, but I'm kind of used to selecting my lines again. Now to the master's bedroom. And to draw that, we can simply connect the walls and recess vertices by 900 to get the door space. We can snap and connect the wall of the bedroom to the kitchen wall as shown, then recess vertex by 900. And this is because we know the width of the door is 900. Once the width of the door is known, this method works. Now we can extend this wall to the door wall and link the wall ends as shown. I think we are done with drawing our partition walls on this architectural floor plan. And when you look at the existing drawing, you realize that we have every room replicated. So we have the living room, we have the anteroom here, we have the toilet here, we have the dining, we have the passage here, then we have the lobby. We have the bedroom one, the master's bedroom, toilet, the store, the kitchen, and then we have the balcony. What's next is to label the rooms and dimension the architectural floor plan. However, that will be done in our next tutorial video on how to use AutoCAD to draw architectural floor plans. We hope that you found our video helpful. Don't forget to subscribe to our channel for more content like this and turn on your notification bell to be first to see our latest videos. Thanks for watching and bye for now.